Hello, pre-algebra folks. This is Chapter 5.2, Adding and Subtracting Like Fractions. Let's launch this chapter with a word problem. One night, 77 1/100ths of the moon's visible surface is illuminated. The next night, an additional 9 1/100ths of the visible surface is illuminated. What fraction of the moon's visible surface is illuminated on the second night? Well, this is quite simply an addition problem. So to find the fraction of the moon's visible surface that's illuminated on the second night, all we have to do is find the sum of 77 1/100ths and 9 1/100ths. 77 1/100ths plus 9 1/100ths. We can rewrite this as 77 plus 9 over 100 because they share a denominator. And then we simply add. 77 plus 9 gives us 86 over 100. We do need to simplify this. 86 over 100 can be reduced to 43/50ths. Ta-da! Done. On the second night, 43/50ths of the visible surface is illuminated. Now let's subtract like fractions. What if we have -4/7 minus 2/7? We simply rewrite over the same denominator, -4 minus 2, giving us -6 over 7, or -6/7. Done. What if we're subtracting a negative fraction? That would give us 1/10 minus -3/10. So we would rewrite this as 1/10. Remember, 2 negatives makes a positive, plus 3/10, giving us a final answer of 1 plus 3 over 10, or 4 over 10, which reduced becomes 2/5. Please try these 4 problems on your own. Press pause while you work, and come back when you're finished for adding and subtracting mixed numbers. All right, folks. Now let's add some mixed numbers. The first step when you want to add mixed numbers is to convert the mixed numbers into improper fractions. So 5 and 5/9 will become an improper fraction, and we calculate that by taking 5 times 9 to get 45, and then we add the numerator 5 to get 50, and we place that back over our original denominator, so 50/9. We repeat the same process with 2 and 7/9. 2 times 9 is 18, plus 7 is 25. We put it back over our original denominator, which is 9. Now we add 50 plus 25 over 9, or 75/9. To finish up this problem, we first reduce. Both 75 and 9 are divisible by 3, so we'll rewrite this as 25/3. Our final step now is to rewrite this as a mixed number. 3 goes into 25 8 times with a remainder of 1. That becomes our new numerator. And 3 remains our denominator. So 5 and 5/9 plus 2 and 7/9 equals 8 and 1/3. Now let's subtract. -10 and 6/13 minus 6 and 8/13. Once again, our first step is to rewrite our mixed numbers as improper fractions. That gives us -136 over 13 minus 86 over 13. So we have -136 minus 86 over 13. -136 minus 86 is -222 over 13. 13 goes into 222 17 times with a remainder of 1 over 13. And don't forget that negative sign. Can't lose that negative sign. So our answer is -17 and 1/13. Now try these 4 problems working with mixed numbers on your own. Some ask you to add, some subtract, and some use negative numbers. Apply everything you know about those concepts, and you should do just fine. Press pause while you work, and there's one final thought in this chapter. The final concept in 5.2 is to simplify variable expressions. Here we have two variable expressions, 3a over 20 plus 5a over 20. We'll begin by adding these just like we'd add any other fraction. 3a plus 5a over 20. Now we add those together to get 8a over 20. We can simplify this because both 8 and 20 are divisible by 4. So we can rewrite this now. Well, here, let's divide our by 4 just so we don't keep track of what we're doing. Remember, 8a is really 8 times a, so this becomes 2a over 5. So the expression 3a over 20 plus 5a over 20 becomes 2a over 5. Let's try one more problem like this before I send you off on your own. In this problem, we have negative 8 over 3b minus negative 2 over 3b. Now we simply solve as we already know how to do. Negative 8 plus 2, remember, two negatives make a positive, over 3b gives us negative 6 over 3b. Both 6 and 3 are divisible by 3. That will give us negative 2 over b. So negative 8 over 3b minus negative 2 over 3b gives us negative 2 over b. When I see you tomorrow, we'll practice more problems like this together. Until then, have a great night.